In this video, we're going to use the famous equation E equals mc squared, where c is the speed of light, to compute the energy equivalence of a free proton, and we're given that the mass of a free proton is about 1.67262 times 10 to the negative 27 kilograms, and we're given the speed of light to 5 significant digits as 2.9979 times 10 to the 8th meters per second. Now the problem is broken down into parts because we actually want to accomplish more than just getting the energy equivalence of the free proton in joules. That's part A. And the focus there is really on keeping track of significant digits correctly. And we're just going to plug in to E equals mc squared here. So before we plug the numbers into a calculator, we just want to consider how many significant digits we should round the answer to. In the mass of the free proton, we were given 6 significant digits, and in the speed of light, we were given 5 significant digits. Because we're multiplying these things, we're going to round our final answer to 5 significant digits. And when we run the numbers on this, we get 1.5033 times 10 to the negative 10 joules. In part B of the problem, we're going to convert this energy into electron volts and then mega electron volts. And the motivation for this is that electron volts are a very convenient unit of energy in atomic and nuclear physics. We're given the conversion from electron volts to joules. 1 electron volt is 1.6022 times 10 to the negative 19 joules. So to get the energy conversion done, we start with the energy of our free proton. Again, that was 1.5033 times 10 to the negative 10 joules. And then we multiply by a conversion factor. Electron volts in the numerator there, joules in the denominator, so they'll cancel out. And then we have to convert from electron volts to mega electron volts. So the mega electron volts go in the numerator. That's the unit we want to have surviving here. And mega means a factor of 1 million. So 1 mega electron volt is 10 to the 6th electron volts. When we do the unit analysis, the joules cancel out, the electron volts cancel out, and we're left with mega electron volts. And when we run the numbers on this, we're left with 938.24 MeV. Again, we keep 5 significant digits because all the numbers we just plugged in were 5 significant digits. Finally, in part C, we're going to express the mass of the free proton in some exotic new units. So the idea is that we take E equals mc squared and we solve for mass. This gives us a new equation. Mass is the energy equivalence of a particle divided by the speed of light squared. And the units that are popular to use in nuclear physics are actually mega electron volts per c squared. So to find the mass of the free proton in these new units, we don't really have to do any new calculations. We simply take the energy equivalence of the free proton in units of MeV. That's 938.24 MeV. And again, the mass of that free proton is given by the energy equivalence divided by c squared. So we've got the mass of the free proton in MeV per c squared, and we're done. If you enjoyed this video, or at least found it useful, check out another one by clicking one of the links on the left. Or click the Joules Lab logo on the right to explore dozens of physics and math playlists. As always, you can leave your questions, comments, and requests in the comments section below, and I'll get back to you within 24 hours. Thanks for watching Joules Lab, and best of luck on your math and physics journey.